The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Happy Election Day, and welcome to the Better Buildings Alliance Renewables Integration Team Call. This is Rose Legner from the National Renewable Energy Laboratory. I'm the technical lead for this Better Buildings Alliance team. I'm very excited to host today's call titled Bridging the Gap Between Efficiency and Demand Response, Integrated Solutions for Utilities and Building Owners. And we'll hear from three speakers today, including Dan York, who is a senior fellow from ACEEE, Craig Wright, who is the Natural and Renewable Resources Manager at Aurora Public Schools in Aurora, Colorado, and Gregg Fischer, the Director of Energy Systems under the Design and Construction Sustainability and Utilities Division of Tishman Speyer. For our new members to these calls, the Better Buildings Alliance serves as a platform for commercial building owners, managers, and industry partners to share and deploy innovative, cost-effective, energy-saving solutions for greater adoptions of advanced technologies, more profitable businesses, and better buildings. The Renewables Integration Team itself focuses on the strategic use of renewables in our commercial building stock, building load flexibility and grid coordination to understand how our building stock can become a better asset to our power grid. And our aim is to provide resources, information, and guidance on these topics to you, building owners and managers, and our other stakeholders who have called into these calls. We also look to our Better Buildings Alliance members for input on possible research or resources needed to help make better decisions on these topics as well. So please don't hesitate to reach out to us. We're always happy to engage in conversations within the Renewables Integration Team focus. Today's agenda for the call is as follows. I will be spending about 10 minutes going over our call introduction and quick announcements. This will be followed by our three technical presentations on efficiency and demand response efforts. And lastly, Theo Kasuga from Navigant and I will be leading a session for Q&A. We'll probably leave about 5 to 10 minutes for that at the end. Please note that this call is being recorded, and we do encourage your participation in the discussion at the end of the call. All attendees are muted, but you can type your questions or comments into the chat box as the presentations proceed. We'll address these questions and comments at the end of the call. So some quick introductions to the Renewables Integration Team. Again, I'm Rose Legner. I'm a senior architectural engineer in the Commercial Buildings Research Group at NREL, and I'm the technical lead for the Renewables Integration Team. We have technical team support from Navigant Consulting. Theo Kasuga is a managing consultant in the energy practice at Navigant. Theo's a variety of topics, including demand response, grid interactive buildings, cost and potential studies, and mandatory efficiency standards. Theo works closely with government agencies, utilities, and consortia to promote building efficiency and interactivity. And also supporting our team is Bill Getzler. He is a managing director at Navigant's energy practice. His work focuses on energy efficiency and renewable energy, providing technology and market assessments, policy analysis, and strategic planning assistance for government agencies, utilities, and manufacturers of building-related products. So these are our key team players. And again, we also work with many Better Buildings Alliance members and other industry experts in the work that we do through this team. So a number of announcements here. I'm really pleased to announce that the Department of Energy and the General Services Administration, GSA, issued a joint RFI, request for information, on October 9th through the GSA Proving Ground, or also known as the GPG program, and through Department of Energy's High Impact Technology Catalyst programs, which is also called the HIT Catalyst program. This RFI is looking for applicants to propose grid interactive efficient building solutions to a number of pre-selected buildings for field study and measurement and verification analysis. The intent of the Grid Interactive Efficient Building Solutions, which are also termed GEB solutions, is to seek coordinated packages of measures, controls, and or energy services that can be implemented in a test site for evaluation of continuous peak demand management, as well as the integration and optimization of multiple building end-use systems, on-site energy generation, and thermal and or battery storage. So more information will be provided in an informational webinar this Thursday, November 7th from 12 to 1 Eastern. The Renewables Integration Team was heavily involved in developing this RFI, so I will be participating on that webinar on Thursday. Hope you can join. And just a quick announcement, I will be sending these slides out with the links to all of this information after the call. So you'll have this in your inboxes soon. Moving on to more announcements, a few publications I want to put out there. DOE published a paper providing an overview of grid interactive efficient buildings in April of this year. I've provided the link on this slide for your reference. And during our call back in April on building load flexibility and grid coordination, we discussed the outcomes of a recent published study by the Rocky Mountain Institute on the value potential for grid interactive efficient buildings in the GSA portfolio. So I've provided another link to this study on this slide. And related to that Rocky Mountain Institute study, Rocky Mountain Institute, or RMI, will be working with NREL to expand their research to analyze 2 additional portfolios. And we're going to be looking to Better Buildings members to participate in this analysis and study. So we've talked to a number of Better Buildings Alliance members already, but we haven't selected the portfolios yet. If you are interested in potentially participating, please send Theo and I an email if that's of interest to you. And lastly, before we jump into our technical presentations, I want to set team calls every couple months. If you missed the last calls on, we had one on building load flexibility and grid coordination and another one on electric vehicles. You can find our slide decks and the recorded presentations on the Better Building Solutions Center. I have the direct links in this slide. And again, I'll be sending these slides out after the call. Similarly, we'll be posting the slides and recording from this call to the Solutions Center, so you'll have access to this presentation as well. And again, if there's any questions that arise, please feel free to email myself at Theo Kasuga with any general questions about the Renewables Integration Team. So moving on to today's presenters, and I'm really excited to have these 3 excellent speakers today. The first speaker will be Dan York. Again, he's an ACEEE Senior Fellow engaged primarily in utilities and local policy research and technical assistance. He focuses on tracking and analyzing trends and emerging issues in utility sector energy efficiency programs. Dan has a bachelor's degree in mechanical engineering from the University of Minnesota. His Master of Science and PhD degrees from the University of Wisconsin-Madison are both in land resources with an emphasis in energy analysis and policy. So I'm going to welcome Dan York to present. And again, if you have questions during his presentations, please write them in the chat box and we'll get to them at the end of the call. Great. Dan?
All right, very good. Just quick check. Coming through okay? Sound check?
Yes, you sound great. Thanks.
Okay. All right. Well, good morning or afternoon, everyone. I'm really happy to be here. Go ahead to that, actually, to the next opening slide beyond this one. That's good. All right. So what I'm talking about today is integration of energy efficiency and demand response programs. Here's the quick outline of what I'm going to be covering what we did for this research project, a little bit on the benefits of why there's interest, brief touching on technologies that are making this possible, and then mostly focusing on the findings, talking a little bit about barriers, and then I'm glad to hear that there's a little discussion of GEBs. We're doing some work in that area too, so I'll just touch lightly on that, which is kind of the next step, if you will, of integrated programs. So next slide, please. Oops.
Sorry, Dan, I'm having slight technical difficulties. Here we go. Hopefully you guys can see my screen again.
All right, there we go. Fine, thank you. All right, so the scope of this research, it really goes way back. I've been with the ACEEE 18 years now, and actually one of my first projects I did back in, I think, about 2005 or so, in those early years, was just looking at peak demand effects of energy efficiency and relationships between demand response and energy efficiency. And fast forward to the present, we were wondering, well, so if it's been a good idea for such a long time, how are we doing? So we wanted to characterize the landscape of integrated programs, see what's out there, then also, if we're not finding so much, what are the benefits, barriers, how are they enabled, and what are the challenges they're facing, and then try to glean out any lessons for integrating programs. Next slide, please. So benefits of integration, this, presuming many of you, this will be old hat, but what we see is there's a whole portfolio of potential benefits and values, starting the ones that are commonly realized that are been very evident. Just the customer bill savings are a big driver. By integrating programs, you can get increased participation and program satisfaction. You know, customers only have to deal potentially with one contact. And part of that results in program efficiency. By combining that, you just have reduced administrative costs for programs. Some emerging benefits, as we call them, is that there's this increased interest in grid reliability and grid modernization, and being able to have two-way communications and controls of customer loads, trying to get those loads to be flexible, which can provide grid congestion relief. And another one that's emerging is the shareholder incentives, trying to make sure that the utility business model or those business models by private providers are there to make this all happen. And then things that are talked about but maybe not quite realized to a large extent yet are the wholesale market benefits and use of some of the ancillary services of grid operation. Next slide, please. And for residential buildings, it's probably no great big news, but smart Wi-Fi enabled thermostats kind of rule as the portal to this whole realm of integrating energy efficiency and demand response. So along with it, AMI, having devices with direct load control switches, and having mobile apps and marketplaces for consumers to acquire these devices and enroll in programs. Next, please. And then commercial buildings, really just scale this up to still smart components and most likely a central control system and equipment with some kind of controls and communications in it, and then tied to the grid, obviously. All right, next, please. And so what did we find? We'll get right to it. So despite all these benefits that have been talked about for years, we really found few fully integrated energy efficiency demand response programs. We started with a set of 52 of the largest utilities as part of some related research we're doing, and we were able to get a hold of 44 utility plans. Of those plans are the program plans, portfolio descriptions, things like that. And we only found 5 programs at the highest level of integration, and 22 of these had some level of integration. And most of the programs we found were residential, and so far that overwhelmed, but it was far more than the C&I program, surprisingly. And then again, smart thermostats are prevalent. That just seems a gateway to integration. Next, please. And so what we wound up doing is, since we found different levels of integration, we just classified those. So we called that there's very basic level, there's some recognition that, hey, there's a program out there. If you're in an energy efficiency program, you could sign up for this demand response program. That's kind of the least level. And then kind of going up there, there's some examples we found where there's cross promotion, where they're more actively trying to recruit participants in either direction. And then next step up would be administrative coordination, where the program teams are really working together. And then finally, the highest level is where you have really a true fully integrated program. Next slide, please. And this is just a rough breakdown. I'm not going to spend much time at it, but again, the greatest number of this 22 that we found was just administrative coordination, and again, just few single fully integrated programs. Next one, please. And we did want to look at examples. Here's just a sampling. AEP had an energy management application for homeowners that kind of provided both types of services, both objectives. PG&E, automated demand response program that they provided additional energy efficient incentives for those signing up for DER. Southern companies looking at smart neighborhoods. I think that's kind of a pilot, but aggregating all the distributed energy resources, both energy efficiency and demand response. Next, please. Just showing one app for AEP, what goes on there with, you have a marketplace to acquire the devices and sign up for an energy bridge, and you have some connected equipment and devices to use those capabilities. Next, please. And I know I'm going a little bit fast, but I'm just kind of laying this out there. Just kind of a quick brush over the work we did. You can certainly dig into the full report. I'll be giving you a link to there later. BG&E, their Peak Rewards program provides customers through a sign up online to get smart thermostats. They're simultaneously enrolled in the demand response and enable them to get a home energy checkup with a few low-cost items, and they're part of the demand response program. They've had thousands of people enrolled because it's opt-out, not opt-in. All right, next one, please. And commercial industrial, I'm just going to touch on these briefly, just kind of showing what we found. Not going to go program by program here, but there's a recognition level where there's, again, making people aware of other opportunities, and that's about as far as it goes so far. I think when I say that, I think a lot of these examples are looking to kind of move up this scale of integration, and they're gaining experience at these other levels. So ComEd and Duke Carolinas both have some programs to sign people up for both DR and EE services. The cross promotion, again, here's ComEd again with some of its other programs are kind of moving up that spectrum. And let's go to the next one here. So I've got a couple out in the East Coast as well, but go ahead. And then commercial industrial, look at more commercial industrial programs. Excel Colorado has their energy management systems program that offers incentives both for the peak demand energy and energy reduction. So they're very clearly targeting both types of savings. And then jumping to the full level of integration, NV Energy, their Power Shift commercial energy services, truly a single program, and wraps everything together for energy efficient equipment and the technologies necessary for demand response and enrollment in such a program. Next one, please. And the barriers and challenges we encounter, or we heard about as we dug into this, was a lot of it just is simply the internal organization of utilities. Things are just set up separately internally with different goals, budgets, funding sources. The business cases are somewhat different, and just coordinating and communicating all that can be a barrier. There's certainly some regulatory hurdles. How do you figure out cost effectiveness of delivering both types of benefits? Just the rate structures and funding mechanisms can work against these programs. There can be conflicting objectives. Demand response, you're trying to save kilowatts, and energy efficiency, you're trying to save kilowatt hours, and the timing of those didn't necessarily matter so much. And then the technologies. We heard tales of, despite all the great technologies out there, there's still interconnection problems and devices speaking to each other and handling all that's necessary to accomplish the kind of integration that's necessary. Next one, please. And I'll be, so just takeaways. Again, we found very few fully integrated programs, but there's a lot of technological innovation, both in software and analytics, as well as hardware, that are creating opportunities for integration. That residential smart thermostat programs are by far and away the biggest offering currently, and that for more integrated programs to be happening, there seems to be a need for organizational changes within utilities and also some private market developments. There's some players out there outside the utilities interested in doing work in this. And you know, as an energy efficiency organization, we want to see more of this happening. All right, next slide. And now I'm just going to very briefly touch on related work we're going to do. And since my time is kind of running low, I'm just going to mention that we're working in this space of grid interactive efficient buildings with funding from DOE. We've got a utilities working group, and we're exploring a lot of the issues. We've got this peer-to-peer network going, and here we found no real programs yet. So next slide. And I'll be wrapping it up here, and you've probably seen diagrams like this of just all what a GEB is. Next one. And again, with looking specifically at GEB, we didn't really find any true what we'd call GEB holistic programs, but there's a lot of steps on the way there. This is the tie to integrated energy efficiency and demand response. They're all kind of fit into this universe of load flexible, efficient buildings. Next slide. These are the barriers that for GEBs that we saw. And let's go to the next one. So again, for all these parts of our website at no charge, just easy to download. So I appreciate that opportunity here to be part of this, and welcome your questions and especially follow-ups after the call. Thank you.
Thanks so much, Dan. We really appreciate you sharing this really interesting research that you've done on these integrated efficiency and demand response programs. Again, we'll be sending these slides out. I'm going to pivot to our other two speakers. They'll both be providing this perspective more of from the building owners and the facility managers side of things. Craig Wright and Gregg Fischer are both Better Buildings members, and Craig Wright will be our next speaker here. Craig Wright is the Natural and Renewable Resources Manager at Aurora Public Schools in Aurora, Colorado. Overseeing the implementation of energy efficient technologies, he has successfully demonstrated innovative advances in automated utility bill processing, building automation system performance, and microgrid applications. Collaboration as a part of the Better Buildings Challenge Energy Analytics campaign, he has also successfully deployed a district-wide analytics and fault detection system. Craig has a bachelor's degree in mechanical engineering and a master's in business administration from CU Boulder. Craig, thanks for joining us today, and I'll hand the slides over to you.
Thank you, Rose. I'm pleased to have the opportunity to have this chance to share with folks interested in this topic of demand response on the past, present, and future of demand response and its presence in Aurora Public Schools. In the past, we had a situation where we were able to participate in a demand response program. Next slide, please. This was a utility rebated pilot program with Xcel Energy that gave us the opportunity to use one building, and I'm sorry for the background noise. I don't know that I can control that. But the utility rebated pilot program was one in which we were able to connect one of our buildings with the local utility via a cloud-based service. And this cloud-based service essentially gave us the ability to not only better understand through very sophisticated analytics the intricacies of the various mechanical systems in our building, but it also gave Xcel Energy the ability to send a demand response signal that essentially told this cloud-based service that was connected directly with our building to change parameters within our building automation system, which it gave them the ability to, immediately curtail demand through this signal sent to the cloud-based service. And it also gave the district the advantage of a technology suite of very sophisticated diagnostic and energy conservation tools. It was a very innovative service, and it was a great partnership. And the demand response aspect of it was fair in terms of its performance, but it didn't meet quite the expectations of the program, unfortunately. But in an ideal world, the demand response signal would have essentially taken the cloud-based, been received by the cloud-based service, and then that cloud-based service would then make changes within our building automation system to our mechanical systems, specifically to change set points on the discharge air of various air handlers, which would remove load from the chiller and also transition to lower fan energy. Next slide, please. So the lessons learned here were that communication is key in all of these endeavors. From the demand response vendor, the ease of connectivity depends on very consistent, well-annotated programming. So in a building automation system, what that means is that you have tagging of various points for the control of your mechanical equipment that is consistent with, and preferably consistent with, project haystack naming conventions, which might be a useful resource for folks to research. Also, the building automation system installation and service provider is a key component to this, the success of this type of program, in that it's important that they be on board and view this as an opportunity and not a threat, that essentially a bolt-on building to their building automation system, which they programmed, is essentially not going to compromise their system's operability. For us, the owner, it's important that we train the technicians on what the system will and will not do, and you obtain, and we wish to obtain better buy-in to their understanding of its limitations, in that it was very precise in terms of what changes it could make, and didn't really translate to security concerns about unintentional overrides. The utility also would have been well served if they also had the technical competency of this type of technology, not just in demand response, but also in their understanding of building automation systems to help support implementation. Next slide. So this is our current project that I'm going to, in a roundabout way, get to, but and speak more in terms of our present and response. And the image that you see here is 120 owned by numerous building types. Namely, we have several schools, well, 4 specifically. We have our transportation department, as you can see by the yellow bus roofs. We also have our IT department and some warehousing facilities, so a very diverse function of use for this campus. And what's interesting is that blue triangle is unique to our school district in that that is a restricted airspace designated by the neighboring Buckley Air Force Base directly to the east of this property, and also means that it limits us to some degree in our construction of what we can build in that particular area, but surprisingly is not restricted to building of solar arrays. Next slide, please. This image shows a rendition of the electrical infrastructure throughout this campus that is currently owned by the utility. And each meter for every building that is metered, and the green square represents the utility transformer serving that particular section of the campus. The concentric circle around those meters in red are also interval meters. They're buildings on which we have installed 15-minute or more frequent interval meters to coincidentally track demand on a real-time basis. The infrastructure of this campus is one such that we believe that it can be consolidated, and with support from the utility, we could potentially acquire these assets and consolidate them behind a single meter. So using the meter information that we have in our EnergyCap database, from billing to the actual real-time tracking, we were able to better understand the nuances of our utility billing versus its real-time utilization. Next slide, please. So this chart is intended to convey the potential savings that could result from transitioning to individual building-specific metered utility metered properties to a more consolidated campus behind a single meter. Taking the consolidated information from our utility bill tracking system, EnergyCap, we were able to compare the real-time interval data and the coincident true demand that occurred at a single point on a particular month. So if looking at the column on the left, those were the individual bills for each of the individual buildings received during the month of April. And what maybe doesn't translate by this image, but hopefully is better explained, is that each of those buildings has their own unique demand that the utility charges, which doesn't happen at a coincident time during the month of April. So that demand amount resulted in a bill for the month of April, roughly 1 megawatts. which our utility charges us a very high rate for demand. It's $23 per kilowatt, and only 3.5 to 4 cents per kilowatt hour. So if we were to basically consolidate all those buildings and their combined usage behind a single meter, we determined, extracting the real-time information from our Energy Cap database, that there was a time precisely at 8:30 in the morning on April 12th, during which we experienced our peak demand for that month. And that translated to a pretty measurable reduction in peak demand, specifically 963 kilowatts. Applying the reduced rate that we would pay if we went to a larger primary general service versus a secondary general service for individual sites, we determined that we could reduce our bill for that month from $20,000 down to $15,000. And this exercise represented roughly 75% of our building area. Next slide, please. So putting the numbers in real perspective, through this exercise, we determined that we could save 13% on our peak KW. Translating that to dollars, we could save roughly $5,000 or 23%. If we applied that to 100% of our building stock on that campus, we would save roughly $6,000, and for an annual savings of $75,000 a year. Next slide, please. So the idea with this would be, clearly there's an advantage to consolidate all the transmission infrastructure on this campus amongst all 10 meters, put everything behind 1 meter, and with the assistance of Excel, hopefully acquire those assets. And hopefully with the addition of a solar array, and specifically we're looking at a canopy over our bus transportation department, we can also provide generation, and perhaps with an EV fleet, utilize the batteries within those buses as storage to provide us with a comprehensive multifunctional microgrid. And that's it for me, and I thank you very much for your time.
Thanks so much, Craig. That's really interesting to hear your perspective, and going back to your participation in the DR program, what worked, what didn't work, where you see more opportunities, and then what you're doing beyond those efficiency and demand response utility programs to manage your demands on your own. So our next speaker, Gregg Fischer, will be providing similar perspectives of how Tishman and Speyer are participating in these DR programs, and then what they're doing beyond that. Just a quick introduction. Gregg Fischer is the Director of Energy Systems under the Design and Construction, Sustainability and Utilities Division of Tishman Speyer. He manages both supply contracts and demand-side energy use for more than 50 million square feet of Class A commercial property, including buildings like the Rockefeller Center in New York, the MetLife building in New York, the Chicago Mercantile Exchange, and the Franklin in Chicago. His central focus is to improve existing building operational ease, energy strategies, and technology systems to ensure the portfolio remains high-performing and competitive in difficult real estate environments. Gregg's previous career endeavors include project management, development, and executive positions at the Train Company, Turnkey and Energy Services Group, and Schneider Electric, Andover Controls. He is a New York State professional engineer and graduated from Boston University with a bachelor's in electrical engineering and Stony Brook University with a master's in global engineering management. So with that, I'll turn it over to Gregg.
Great, thank you. So hello everybody, good morning and good afternoon. I'm Gregg Fischer. I handle a lot of the energy management for our U.S. portfolio, as Rose was describing. So we have, most of our properties are located in New York, about half of our U.S. portfolio, but pretty much every major city west of New York, we have at least one property. So what we do across the nation, what our mentality is we want to certainly make our buildings the most efficient that they can be. There's always a desire to get to net zero at our buildings, and that's going to certainly take a lot of time and effort to get there, but definitely achievable with both the procurement of energy, participation in programs like demand response and a lot of the incentive programs were described, and also listening to our tenants. We have 2,000 some odd companies that occupy our facilities globally, and listening to them and their needs and learning about their corporate goals and initiatives are very important to our company and to keep going forward. So next slide, please. And you can skip me. You gave a great introduction. So like I said, Tishman Speyer was established in the late 70s. We have 80,000 square feet of Class A commercial office space. We're in 30 markets, 7 countries, 4 continents. A variety of divisions within our company. My group being the Sustainability and Utilities group. Next slide. So jumping into temporary demand reduction, I'm going to go through a couple of different scenarios that we utilize on a daily basis, both temporarily and permanently. Temporary demand reduction and the programs that we participate in right now include the New York, PJM, New England, and California ISOs. The programs you can see there, and the frequency at which we get called for the past 5-6 years, you could see in that chart there. We employ a variety of different strategies based off of the technologies that are located in the buildings and also the marketplace that it's in. One of the most lucrative marketplaces to participate in demand response is New York, with Con Ed's CSRP and DLRP that incentivize the reserve payments at $18 per kW for each one of the programs. So we participate very heavily in New York and also in the PJM marketplace, and have been growing ever since. Since I came on board a couple of years back, we've been growing into the California marketplace and New England marketplace, and increasing our reserve commitments in New York and Chicago, DC area. So each one of our major participation areas are in the chart below, and some of the strategies that we do in each one of the properties. So in the case of New York, we have the ability to do fuel switching. So a lot of our chilling equipment across the portfolio in New York is steam driven. So steam turbines typically, and some absorbers. But the ability to have electric chillers and a hybrid plant to switch between steam and electric is very valuable to us, especially when participating in demand response. We also have a couple of buildings that have thermal storage, which I'll get to in a minute, for our permanent demand reduction strategies, but is very useful during demand response as well. Pretty much in all of the different regions, we participate with our base building air handling units and reducing fan speeds. So variable frequency drives and building automation systems help us reduce any sort of waste fan speed that we have. So we have been we reduce fan speeds. Also, we do some things that because we have spare capacity in our central plant and our chilling equipment, we employ some low flow, low temp strategies where we reduce the supply temperatures coming out of our central plants and going to our air handling units, so fans can discharging colder water into the air handling units is ultimately going to reduce our pumping efforts and our flow requirements. So keeping the same tonnage, but burdening the chillers a little bit more with their ability to cool that water is how we participate in specifically the New England marketplace because of the steam-driven machines there. But yeah, a variety of lighting, exhaust fans, reductions in our heat, and specifically within California, we have recent battery storage installations, and those are going to continue into most likely the Boston region next, and DC and New York to follow after that. Next slide, please. This is an example of one of the things that we post in our lobbies across the nation when we participate in demand, and also in our elevators, the captive experience, telling you the news and the weather and whatnot. But the energy conservation days are something that we like when we do get demand response events, and some voluntary demand response events throughout the nation. And we ask tenants to help us participate. All of our demand response revenues go towards our tenants anyway. This is not something that goes towards Tishman Speyer. They help pay for the energy bills of our tenants. So we do encourage the participation by shutting off unneeded equipment and lowering shades and blinds, turning off lights that aren't necessary during the day while we do have these events. But I typically activate the ECD, the Energy Conservation Day, throughout the nation based off of the weather that's being experienced and how taxed the grid is at that moment, the publicized numbers. Next slide. So this is one of our thermal stations at Rockefeller Center. We now have 20 hours of the equivalent of 2 million pounds of ice that we produce pretty much every night for probably 250 days out of the year during our peak seasons, the shoulder seasons in summer. Our most recent installation at our global headquarters at 45 Rock was a good 11,000 ton hours of that 20,000, and we've seen some crazy savings that were far exceeded the anticipated savings that we were shooting for. Utility incentives were tremendous. So if anybody is aware of the Demand Management Program, Demand Management Program 2 that Con Ed was running, they were incentivizing the reduction in demand tremendously. And it seems like with the closing of Indian Point just north of the city, the need to continue that demand management program to permanently reduce demand is going to continue. That is not publicly announced yet or confirmed, but it's things like these, like thermal storage, which is the legal storage within the FDNY territory. Battery storage, lithium-ion batteries are still restricted for indoor installations. So we resort to storing our energy in the form of ice at 4 of our facilities within the city, and using that ice to cool the building in the middle of the day when we get charged the most for our electricity. Next slide. So one of the things that we use are our energy monitoring systems to understand how well we're doing during demand response events and for our permanent demand reduction. Our energy monitoring system does a great job in converting engineering units into dollars. That is our of our tenants and our internal apartments and how well doing in the portfolio. If you see the tile all the way to the bottom left, and not the one that I'm pointing to, but the performance versus expected, that is a tile that is posted in each one of our 45 control rooms across the nation. That actually ranks each one of the buildings and the operations teams in how well they're reducing their energy for that quarter. We have an incentive program for our operations staff to find wasteful uses of energy and to reduce them, and that is our energy monitoring system tracks that as they go throughout the quarter, and then throughout the year we have quarterly prizes and incentives, and then a yearly building of the year. But we track our live demand management and during demand response events because of the way we get charged for electricity in some of our jurisdictions. There are points when we do participate in demand response where we are pre-cooling our facilities and then performing in demand response and then turning all of our systems back on to handle the increased load in our facility. And what that does is it actually peaks us out in some ways. So I think one of the ways that can remedy the ratchet demands that we are subject to in our delivery charges is to maybe provide some relief during demand response days, so that we can pre-cool effectively, reduce our demand during 4-hour demand response windows, and then come back online and do what we need to do in the facilities. But tariff structures, I believe, are evolving and sort of lending itself to more storage and demand response calls. Next slide, please. So we have a variety of technologies in our facilities. You've seen a cross section of the building and all the different systems that are in buildings before. But if you go to the next animation, all of those systems provide a tremendous amount of data. So what do we do with all that data? If you go to the next animation. We want to organize it and participate in a lot of things that require a lot of data, but are not easily organized by humans to actually give us good feedback on things. So we rely on real-time dashboards, machine learning, notifications, real-time processing from all of these data sources, and to provide us good information in running our facilities the most efficient that they can be. But if you go to the next slide, Rose. This is certainly a work in progress, and what we're relying on is the Tritium Niagara framework, where we can integrate a lot of different things in our facilities, a lot of different systems that talk a lot of different languages, and can easily provide a single pane of glass approach to our systems that is going to keep growing. If you Rose, one more. That is going to keep growing to and what our platform is going to be used is anywhere from our tenants all the way down to the operators, engineers, my internal personnel. All will start using this single pane of glass to better understand our buildings and get the pieces of information that they need. Next slide. And then we want to deploy this across the entire nation. We're starting out in Rockefeller Center and upgrading all of our building automation and integration strategies. But we do plan on expanding to the rest of our portfolio globally, so that we can see all of our buildings across the nation and participate in demand response and permanent demand reduction the best that we can. And I believe that's it. And thank you, everybody.
Great. Thanks so much, Greg. It's just really exciting to hear from all of you guys, and you, Craig and Greg, about what's happening in real buildings. And I think we are really at this opportunity where we have the technology to meter our buildings, collect the data, and implement not just these efficiency controls, but these continuous demand management controls. And then link that to these programs that are emerged that Dan nicely summarized at the beginning of the call. So with that, again, I encourage you guys to type your questions. We have a few here. I am going to just dive in. First, Dan, I have a question for you. Could you speak a little bit more about the specifics of the commercial industrial program findings and why you think they are not as far along as the residential side?
Well, let's see, for the commercial industrial, it seems that there's more emphasis on just the smart building part of it without connecting to the grid. And I think maybe the other two presentations kind of touched on some of the additional challenges of having more complicated systems that all have to talk to each other and work it out. So I just think that some of that might be the barrier. For the residential programs, it seems like the smart thermostat was just an easy entry point that doesn't take too much to pull off. So the commercial programs, I think there's still great opportunities there, and I think that's where a lot of the effort's going to be going to overcome some of those barriers that we identified. But just because there is a greater probably potential saving system-wide, and those are the kind of loads, those bigger loads, I'm sure grid operators love to be able to manage rather than a whole thousands and thousands of individual residential customers.
Great, thank you. And I think this, integration and the control systems is a question that I actually have, and I'm just going to ask my own question here, but more for Greg too, with your system control that you're using. Are you still addressing each building and use them in a siloed manner, or do controls offer more integration or even across the buildings and understanding what's together as one? Greg, are you on the line still?
Rose, looks like we lost Greg. He's trying to call back in, but we don't have him on the line right now.
Okay, thanks. Okay, we'll move on from then. There's two questions for Greg, so once he calls back in, we can jump to those. Craig, this is a question for you, actually. I'm curious about your experience with the Excel program and the demand response program there, and how often were they sending you signals to curtail demand?
Well, it was just a pilot program and just a trial attempt. They needed a subscriber to be able to accept this type of web-based to interface with the building automation system such that it would eventually accept the signal. And then there were a couple trials, but it didn't quite be they had desired. So it was dropped. But a successful implementation, I could foresee a very successful implementation of it. It just requires the level of communication among the parties that I indicated.
Yeah, that was very useful lesson learned on that, and I'm sure for all stakeholders in that process. Okay, great. And then do we have Greg back on?
Yeah, I'm here. Sorry about that.
Oh, no problem here. It's the top of the hour, so I want to go through this quickly. Maybe a quick question here that was asked by an attendee, wondering about the electric heat reduction program and if that was reheat or just a couple more details on how that program was actually implemented.
So so what we're going to be doing in the Boston facilities is actually doing some energy storage with heating hot water with electricity, and storing that hot water when it's needed the most. So it's maybe not heat reduction, but heat storage and and electric leveling, load leveling during heating season is more appropriate terminology. But that's ultimately what we're participating in.
Great. Okay, and then I'm going to squeeze one last little question that I had, and that was about your system controls, Gregg, and it seems like it's starting to be more and more integrated, but I was wondering if your control system looks at multiple building end uses and their operation together, or if the controls are still very siloed in how those specific end use systems operate.
Everything is very siloed at the moment, but is becoming integrated across buildings. New York is going to be our first region, just because that's our headquarters, and all of our buildings are within a couple block radius. So it's easy to start integrating those together, and we're ultimately going to be creating a centralized energy sort of control board, where my team is going to be able to see all of our buildings on that single pane of glass. But going to start out regionally and then expand to the rest of the U.S. and then globally.
Wonderful. That's really exciting. Okay, with that, we are at the top of the hour, a couple minutes beyond. I really want to thank our presenters today. You guys gave really exciting presentations, and I hope this was really valuable to our audience. And thanks to everybody in the audience for calling in. Okay, stay tuned for announcements of our upcoming Better Buildings Alliance Renewables Integration team calls. You'll see emails from both myself, Rose Langner, and Theo Kasuga from Navigant. Thanks, everyone. Appreciate your time today.
Thank you.
Thank you.
Thanks.